So last time, what we saw is how about processing of waste management, as in like solid waste management, and what was happening. So this time, what we're going to do and methods of disposal, all of which what we saw. Today, what we're going to look into is waste minimization, reduction at source and recycling, waste processing with recovery of resources and energy, waste transformation without recovery of resources and disposal on land, emerging process of technologies, organic waste, biomethanation, vermicomposting, and organic waste converter. These are not something new what we're going to look into. These are pretty much what we covered from the last class itself. But again, regarding waste minimization and waste management, so I picked up a presentation as this is a presentation not done by me. This I've just found on net where it's easy to use. Okay, before starting on to it, as the terminology is clearly defined, what is waste minimization? What is the understanding of it? Waste
Reduce.
minimization, reduction. Yeah,
Yes, sir.
it's very straightforward, right? So, what do you take from it? Anyone? We saw how the solid waste is produced. We saw what all ways it can be segregated, and what all the genres of it: medical waste, industry waste, household waste, agricultural waste, and then we went into the process of how to process each of them. What are the various methods available? And what are the ways in which we can reuse? So we got a complete package here, right? Now, what is the need for this topic?
So, like, if you don't produce more waste, if you reduce the amount of waste you produce, then further the segregation and everything would become easier. Like, when you don't even produce waste, why would you want to process the waste? It's like that.
Yes. So thing is, we really can't. Yeah, Sona, you got a point to say. Sona, you have raised your hand. What is it?
No, sir.
Yeah. Share your thoughts. Yeah. Sona.
Yes, sir.
So you raised your
No,
hand.
sir.
Yeah.
Yeah, that was by mistake, sir.
Oh, okay. So you don't have a
Sorry,
point to
sir.
say about waste reduction.
Yeah, so it focuses on preventing waste from reducing the amount of toxicity of hazardous waste generated.
Yeah, that is one minute point in it. As like, okay, that comes into reducing the toxicity. But otherwise, what is the requirement of waste minimization at production level itself? This is not about end user. Like, see, there is a product which has been developed, and eventually, while we use it, we tend to be managing it. But there is something called waste minimization at the production stage itself. It's definitely, like Gayatri mentioned, yes, the reason of we not producing waste, and it definitely takes off the reason of segregating it and processing it. It can't be completely avoided, but it can be used efficiently. Like how the production level, the waste management can be taken up in the production stage itself. Not that the waste is what comes to the next level, as like a product is done, and then we, as a user, we try to minimize one stage. But what is that waste management at the top level? So this is what the presentation we're going to look into, and you'll know the reasons here. So the reason of waste minimization, what is the energy required to produce it? See, when a product has been produced, what is the quantity of product to be produced is what we define it. I'm saying this as a raw material, as any product. This particularly goes into product which has got a shelf life, where like, okay, we produce so much of material, but there's not much of demand to it, then no point in producing it. So here, first for the energy required by the industry to produce it, that is a waste. And then the later part, once it turns into a waste, it reduces the total cost. We don't need to be processing, okay, collection, segregation, intermediate storage, all these. And what is the profitability? So this comes into generation of less waste, consumption of fewer raw materials, and less energy. Again, as I mentioned you, there cannot be a zero waste from any manufacturing process. There is definitely going to be waste from the manufacturing. When it comes to us, we are the users of it. But here we say about the manufacturing. This speaks of what are the various. This is already what we spoke about from the waste management. So I'm not going to go through the same. Energy recovery, landfill. This is again what we saw about waste management. Now here comes the important part. So what are the strategies? What are the methods in which this waste reduction can be taken up into? Inventory management. Inventory management is knowing what exactly is the stock and what exactly is the output required, and then go for the usage. Production process modification. See, guys, these are all what I'm mentioning about waste reduction. This is all the process taken for the manufacturing of it. But again, these can be similarly interpreted for the usage also, as a user. If I say about manufacturing process, I'll say the industry needs to have an inventory of what is the materials they hold with them at that current situation, and what is the material they're going to require in manufacturing, and then they know what is the time period in which they're going to exhaust it. Whereas if I say about a user as myself, then inventory management is, if I'm going to buy any product, I need to be sure that whether do I have a stock of that product, what is the amount of time I would exhaust my resource. Then I'll make a decision on what is the quantity I need to buy. This could be as easy example as what is the vegetable stock at home, then what is that we are going to, how much we are planning to buy, and at what time we can use it efficiently without wasting anything. So this can be taken in both the ways. Production process modification. That is including, production includes a lot of machineries and energy is worked on it. So how about making efficient use of it? That's again a waste reduction technique. Simple example is energy used from thermal production can be taken up into something like a renewable energy use. If there is a river or stream, how about getting hydroelectricity? If there is a good airflow around that area, how about using the wind turbines? If there is a, definitely solar is one, not definitely not a questionable use. You can definitely think of solar. So again, this reduces the waste. Reduction of waste here is, we are not going to burn any fossil fuel to produce energy. We are using clean energy. So this again, volume reduction is, we don't say volume reduction, we say volume appropriation. And recovery is, what is that, even if it is being produced as a waste, what is that we can recover out of it. So inventory management. You guys are clear? Am I going too fast?
No.
Guys?
No, sir, it's clear.
Are you guys clear that I'm speaking of two different processes? One is about the industrial process, another one as a user.
Yes, sir.
Okay.
Sure.
So again, inventory management is divided into two: inventory control and material control. This is what I've already mentioned, but we can just have a read through. I'll share the same content with you. I don't want to read the same part. Yeah, a simple point, it involves techniques to reduce the inventory size, hazardous chemical use while increasing inventory turnover, proper inventory control. Inventory is nothing but what is a ledger in which what is the amount of stock, what is the production we're going to use. Material control, proper control over the storage of raw materials, products, process waste, minimize the losses through spills and leaks. This thing regarding the materials, I'm not sure if you're following news. Like now, recently we have summer showers. Rather, like we had a rain a week back, which is not expected during the summer. Well, what happened is the government stock of grains, what they procure from the farmers, they kept it for storage on a outdoor environment. And because the rains, they couldn't have enough time to cover up all the materials. So the grains got soaked in rain and they all been wasted up. This is one example. So there are various ways. So I'd say proper control over storage of raw materials. If you want to take it in the sake of user, as at home, the water leaking through a tap is a perfect example of it. That is, again, we do have a material, but we are not using it. We are wasting it. Probably the only reason is we are not taking enough caution to fix that small leak. But that is what amounting to a waste also. That's like minimize the loss through spills, leaks, and contamination. Ensure the material is efficiently handled and used in the production process and does not become waste. Production process of modification. 3 techniques of production: operation and maintenance procedures, material change, and equipment modification. One ideal example is cars and bikes. The cars and bikes require this is just an example, so don't take this as little, this just for understanding. They require a constant maintenance. What happens when, okay, we are not spending enough money to have maintenance for a car or vehicle, the parts get deteriorated. That means it loses its life cycle value. So hence, this applies same for production in the industries of all the equipments also. So for a efficient use, operation and maintenance procedure, material changes, and equipment modification. Equipment modification, one perfect example I can give you for as a user. Normally we have taps with a water flow, which is a normal running water flow. But if you see in all of these lead buildings are given, the taps would have a mist kind of a flow. So which means it minimizes the use of water. So that's an equipment modification. Another easier example which anyone can relate to is what I told you, right, regarding the energy use. What is the energy use as in from solar as well as thermal? A simple example is what we use as a conventional tube light as a CFL, tube light, chlorofluorine tube light. We can change it to LED. There's going to be initial cost in buying a material which is going to be expensive. Again, this comparatively reduces the amount of energy consumed, which saves energy and doesn't take into waste. Operation and maintenance. Okay, these are ones which spoken about. So again, in pharmaceutical companies, this is an example in the pharmaceutical companies. Replace solvent-based tablets putting into a water base. Volume reduction. This we already, from the last topic, segregation of waste allows them to be more readily removed and recovered. Concentrate waste through separation process such as filtration, centrifugation, membrane separation, and evaporation. This is for liquid waste. So what is the on-site and off-site recovery? On-site recovery is a process where when it's manufactured, when it's taken into consideration as a raw material. Off-site recovery is a process where when the material is consumed or used, how it can be done. I'm not sure whether you've come across this life cycle assessment. Have you guys heard of this term? LCA?
No, sir.
Guys?
No, sir.
No, sir.
Life cycle assessment is one important part of sustainability. What the life cycle assessment is, we have a product, and this particular product, from the time when it's procured as a raw material and the time it goes into the industry as a production, what all resources it uses up, and then from the production it goes into a packaging and transportation for users. And once it reaches the users, what is the amount of energy utilized in using that material, and till the time that goes as a waste and it goes for disposal. So what there are one example of terminology used for life cycle assessment is cradle to death. What is the amount of energy required? Cradle is what we have the babies put up, right? So it's from the birth till the death, cradle to death. What is the amount of energy required? So the definition and evaluation of the environmental effects associated with any given activity from the initial gather raw material from earth until the point which all residuals are returned to the earth. This can give you a very good insight on how these energy efficiency ratings like Griha, LEED, Ashokam, there are various energy efficiency bodies, ECPC. So these bodies formulate a lot of points based on life cycle assessment. When they say one important points of sustainable building is using building materials, building workforce from the local region. This means you don't need to waste energy on unwanted transportation. One example of it, while we are saying sustainable building development, I'm going to use a local product. We are very fancy about these products of Italian marbles. As the name suggests, are marbles which are not produced locally. They are marbles coming from one particular region. What is the amount of energy used in extracting from the rock, and the amount of energy utilized in processing that particular material? And after processing, this particular material is put for packaging and imported into various parts of the world. What is the amount of energy spent on transporting? And again, that amount of energy of transporting varies with what all the various factors. Either if it goes through shipping, it spends a substantial amount of energy. If it goes through a air flight, then it goes through another highly energy consuming, and then it reaches a place and then it used up, and the time period. So these are the values which will define what is the life cycle assessment. Another definition of, so that is one example of saying how much of energy utilized when you are using a material, even when it's from a faraway place. In local terms, if I say, okay, I want to use a marble which is coming from Jaipur, again, if it's going to be traveling through road and coming, even that is a very substantially high energy consumption, and the life cycle assessment of the material would be very high. As like, if the value would be very high, we want to try to minimize that value and utilize it to the more. A systematic inventory and comprehensive assessment of the environmental effects of two or more alternative activities involving defined products in defined space, including all steps and co-products. This definition is not much required. Rather, we can use this definition much easier. As I said, what is the life cycle? Stages in life cycle. Raw material acquisition, the material processing of from a raw material. This could be taken for anything. You can take for building materials, or you can take for any consumer goods. All of it is applicable. Every product in the world has got the life cycle assessment value. Material acquisition, material processing, engineered and specialty material production, that is in the manufacturing stage, manufacturing and assembly, use and service, retirement, and then dispose. This is one example for you guys. Life cycle of a chocolate. The chocolate not normally used. What is the life cycle product? What are the amount of stages it goes through? Cocoa cultivation, the amount of energy used for it. For a cocoa cultivation, what is required? Fertilizers and pesticides to save the crop. Then harvesting and fermentation and drying of the product. Bagging and storage. For the bagging, what type of bagging we require? Here, the example is a jute bag. Jute bag. For jute bag, what happens? You need to have a jute cultivation, and then you have to go through a jute harvesting, and then you have to go through manufacturing. Once the packaging is done, transport of beans to processing factory. Your industrial cleaning, roasting, breaking, and winnowing and grinding of cocoa beans. Mixing of cocoa liquor, cocoa butter, milk, sugar, and other ingredients. For this, sugar production is another industrial production. Milk production depends what source of milk we are going to use. Conching and refining, tempering and molding, chocolate packaging, for which we need a packaging material, distribution and retail, consumption phase as a user when we use it, expired food packaging, disposal. So this is how simple what we think as a chocolate, amount of process goes through and the amount of energy required is so much. And imagine these are all locally done. Like if you're going to think about imported chocolate, then again, the transportation of that from where in this phase, distribution and retail, the value goes high. Great, clear? Is the following?
Yes, sir.
Yeah.
Yes, sir.
Yeah. So what is environmental? Now it comes to the term of environmental impact assessment. There is a new act also. EIA is being passed by the government. Are you guys aware of it?
Yes, sir.
What was there's a big fight over it. Can anyone say what is happening locally in the government?
I am not aware about the fight,
They're saying all the
but
projects.
I've heard about this.
Yes. What did you hear about it?
Like I know, like they have this inspection before the processing and after the processing. Like from the
Yes.
beginning to the end of the thing, they go for inspection now over the project.
Environmental impact assessment, as a term which is put straightforward, it says any development, any process that you're going to start up, it has to get a clearance for what is the environmental impact assessment. What would be the effect of it to the environment? Imagine now, what is the footprint of your development? What is the amount of energy you're going to use on that? What is the consequences of that development happening there and to the surroundings? One way easily, if you can relate, could be if at all a high-rise development is being put up. Environmental impact assessment would ask for what is the amount of water resource you might require to use here. Do you have that value you're going to source it from? What happens normally? What happens when this assessment is not done? What are the high buildings doing here? How are they procuring water? Guys, the questions to you guys. You see all these big developments, right? Residential projects, commercial projects. Earlier, there never used to be environmental impact assessment, but now there's come into a lot. How do you think they manage it? It's come in a lot of movies also these days. Any big development?
They
Yeah.
they did bores for the
Sorry. Can you please
they did
repeat?
bo- they did bores no sir for the water.
Yes. They're going to use the groundwater. But what happens is that one source of groundwater would be enough to. The reason why I said is high-rise developments, the big commercial developments. These are projects which is going to substantially use a very large quantity of water. So what they do is they try to exploit all the amount of first drilling up bores, and they'll definitely reduce the water table, and there'll be so many number of bores which will be taken up, and the water table in that particular region would have a major impact from one development itself. Otherwise, there could be a water source which they could have found as a lake somewhere close by. They can exhaust the whole resource of it. So this kind of environmental impact assessment, these are examples. So what are the cautious concerns? Even the waste disposal. As I said about any development, if they're going to use so much of resource, definitely they have to dispose also so much of resource. Where are they going to dispose it? So this was put for a debate with the government, saying that this is wherein the lot of points which are being like not friendly for the humans, as like it's more like an industrial process. It's not applicable to a lot of common people. So that's what they are asking for, a review of the same. And I think later on, I'm not sure what happened, but that's what creating a lot of fuss when the government launched it. But comparatively, this is a good initiative to take up these issues. So any like industries, if you look into tanning industry, the very easy way of if you disposal of their liquid waste would be putting onto the closest water body, a stream, a river, which leads into old contamination. If environmental impact assessment is done, then they would be questioned on what is the methodology they're going to be used in taking up a disposal. If they don't have enough concern on that, then their approval won't be sanctioned. So, what are the various concerns of environmental impact assessment? Is visual impact, air emissions from the development, water discharge, ash discharge. Concern about human health, exposure of pollutant emission, ingestion via food chain, water and inhalation, fauna and flora, loss of habitat. If the development is not so friendly, then it can lose the natural flora and fauna of the region. Site operation, traffic, socio-economic impact, land use, and cultural heritage. So here, what are the various processes in EIA, environmental impact assessment, to decide which project should subject to environmental assessment? Is a setup process which defines the key issues. You can go through this. This is what we spoke of already. So that's about environmental impact. The reason why we are going through all of this life cycle assessment, environmental impact assessment, and integrated waste management. These are all steps which enable us in waste reduction in the manufacture as a usage. Integrated waste management is we know about this. What are the different kinds of waste? How each waste can be segregated, and what is the way in which it can be utilized? That is integrated waste management. So, if you want to know on the term definition of it, defined as integrated streams, collections, and treatment methods, environmental benefits, economic optimization, and social acceptability into practical system of any region. Implies a use of range of different treatments and disposal options. No one option is better than other, but it is the best environmentally or economically sustainable at particular region. Economic sustainable. As I said, a proper waste disposal is environmentally friendly, as well as economically we can get a lot out of it from a waste. This again is a simple process wherein you have to read the circle from outside to the inside. So if at all we just say about material recycling, we can directly go into collection and sorting. Whereas if we say about landfill, we try to extract the landfill with the gas use, as in what is the biogas or something, then we can take into what is the process in which you can utilize. Thermal treatment, incineration without energy, that is left to decay with the normal sunlight. Mass burning, fuel burning, and after the burning, what is left over can be collected and sorted. Biological treatment, composting, and from the composting, what you get? Again, biogasification is methane production, and what is the way in which you can utilize. This is integrated waste management. The same definitions are here. This again, the process which I said has been put up here as a flow chart. So this is the end of the slide. Yes. So what do you understand from this, guys? What is your take from this? Are you all listening here?
Yes, sir. Listening.
Yes, sir.
Yes.
So what is your take from this? What is that you're going to be taking up? How different is this from the earlier waste management and methods we saw? Response?
So this is to much larger scale than the previous one.
Not really, Gayatri. This is to, even if you take in a smaller scale, very small industry also, this would definitely meet a have an impact with the environment. As in, like anything to do with waste generation, even a very small, what is a small industry you can think of? A small usage. As I said, as a home, when we consider as an individual, we don't think we produce much waste. But even if we apply all these principles to us, what are we really doing into? We reduce the amount of waste substantially. Like the simple sticker what we see in a classroom saying that when no one's turn off lights and fans, don't waste energy. So those are very small steps, but it plays a vital role in the waste reduction. And this is just not again, this subject and knowing about all of these contents and building services is just not a usage for subject wise alone, but it can make us think much more humanly towards nature, as like what is our each of us consuming, what is our disposal, how we can save energy, how we can reduce the waste what we produce. This makes a big difference.
Yes, sir.
But I'm not sure it's like one person responding. Oh, why is that no others? You guys don't have any opinion regarding this? Guys,
In a way, it's more conservative.
it's not about more conservative, it's about being conservative. Conservative and concerned.
Yes, sir.
See, I would like to show you another example. This is not a totally a holistic process, but again, these are trends and technology in which one kind of waste can be used as a resource and try to minimize the total waste. It's just mutually workable. Have you guys heard of something called hydroponics? Guys, have you guys heard of hydroponics?
No, sir.
Hmm?
No, sir.
Hydroponics is a technique in which plants are grown without soil, wherein it's just fed with water and the minerals are added to it. That is hydroponics. And there is these are again emerging trend in agriculture, especially used in urban spaces where like not much agricultural land is available, wherein the soil condition is not. But these are much more like an engineered way of doing a cultivation. This comes into a smaller scale, a very big scale, but a lot of developed countries have been adopting it. Especially if you see Singapore, they got a very big way with hydroponics, and there is another one which is called as aquaponics. Aquaponics is using fish and the waste from it this is aquaponics, a combination of aquaculture, which is growing fish and other aquatic animals, and hydroponics, combination of growing fish and hydroponics, growing plants without soil. Aquaponics use these two in symbiotic conditions in which the plants are fed with aquatic animal discharge of waste. In return, the vegetable clean the water that the fish goes back to. So, effectively, this would be the process, one simple layout of it. So here, again, what happens is the waste is not taken as a waste and then it's processed and then it's treated and used here. Whereas it is again put to the nature and wherein it takes up into a comprehensive process wherein each of it works symbiotically. The fish waste is taken by the plants to get the nutrients, whereas the plants in turn clean the water from the waste and send it back to them. So again, these are one or two thoughts about it, but there are various other processes. As architects, what is our contribution to it? Definitely with the building industry, we produce a substantial amount of waste. Construction waste, the materials what we procure, as in what we design for, where are we sourcing it from, and what is the technology we adopt and use. Okay, a simple example is, which of the material, okay, you guys have heard of bricks, right? The bricks, normal common bricks.
Yes, sir.
Yes, sir.
Okay. Are you guys aware there are two types of bricks? Probably I can say, yeah, we can put it as two types. One is sun-dried and another one is oven-dried bricks.
Yes, sir.
Yes, sir.
So, what do you think would be the life cycle assessment of which brick would be better or which brick would be consuming more energy just for processing of it? And again, the life cycle is again what is the amount of time used for it, so on goes on. Which one of it would you think will be much more energy consuming?
So oven-dried bricks.
Oven-dried bricks.
How do you come to a conclusion on that?
So, because we use energy from combustion for oven-dried bricks.
Yes, that is the only one extra step what we do. But again, think of the factor. But definitely there are various other factors. There is another brick which is much more not energy conservative, which is bricks which are the wire cut bricks. They go through a much more industrial process in doing a proper brick, wherein it takes in much more amount of energy. So each of these products, as architects, we need to be aware of. I'm not saying use a material which is at the lowest energy consumption, but use it to a very conservative way, conscious way, in which we can reduce the amount of contents. Again, I can give a conflict of the same. Can I again defend saying how a wire cut brick is much more efficient than a clay dried brick, sun-dried brick? Is there a point wherein I can defend on? I'm asking you guys. Can I come back and say a wire cut brick is much more efficient and less energy consuming than a sun-dried brick? Is there a possibility?
In terms of human labor, maybe, sir.
One
Like
is UV
wire.
vapor. You're slightly closer to it. Another one is if a wire cut bricks are used, then the finish of the wire cut brick is going to be much more finer, wherein you don't need to be
It is
plastering
more.
it.
It is easy to work with.
That is true, easy to work with, but again, imagine how if you're not going to plaster it using a cement mortar, then you're not going to go for a finish on it. You're not going to put a first thing, you're reducing your plastering cost. Next is you're reducing the finishing, the amount of putty to smoothen the wall, then the 2 or 3 coats of paint what you go through. So you totally avoid these materials, right? So
Yes.
again, as architects, we should be rational enough to think and say how, wherein at one point the energy consumption can be high, but the same thing on the next part, how it can affect also. It can reflect another way, wherein it says it is much more energy friendly. You guys are able to understand this?
Yes, sir.
As in rational thinking of material is not just that looking at numbers and we coming into a conclusion, but what are the after effects of it and what can be done. The same part, the life cycle of a brick is you pick up from a raw material, then you process the sand or clay, and then you mold it, then you let it for uh, either go for a sun dry, or you go for a oven dry, or you go for a wire cut, and then go for a baking, and then it is taken into a transportation, utilized at the site, and from the site, it's just not through the till the demolition. If the life cycle of the brick can be utilized more, the bricks which are used in the second-hand market, wherein the bricks, if once they're demolishing, if they can be tried to remove as with the very minimal damage, then it can extend its life cycle and go through another reuse. Otherwise, it can be crushed back as a powder and probably can go through another process. So this is one example as a life cycle of a brick. Same thing as materials, as finishing materials. What are the materials available regionally, which can work in a much more energy, less energy consumption. What do we say as a waste in transportation is the amount of fuel consumed in bringing that product from one place to another and amount of emission happening from that through that transportation. All of these are considered as waste and effects to the environment. Yeah.
Yes, sir.
Okay. So this is about waste minimization, waste processing, and waste transformation. The last part is organic waste. You guys know what is an organic waste?
Yes, sir.
Organic waste.
Yes, sir.
Yes, sir.
What is it? You can say it in your own understanding, not a
So,
problem.
biodegradable waste.
Yes. Any organic material, any waste, which is a organic material or material, living material, which goes through a decomposition, is called organic waste. And what process is adopted? So there are 3 parts in which it's being put up as biomethanation. Biomethanation is nothing but have a waste stored in a space without any oxygen intervention. The organic waste goes through a degradation. This degradation process, decomposing process, will produce methane. And this methane can be captured and used. Again, this is a very cautious process. The reason is methane is a what? What type of gas is that?
Greenhouse gas, sir.
Perfect. Greenhouse gas. What is the effect of a greenhouse gas on the environment?
Traps heat.
Yes. But what happens when there is a more amount of methane going onto the atmosphere? Guys, we are speaking of global warming. What is that? The more amount of methane going into the atmosphere definitely increase the amount of greenhouse gas. Do you guys realize that or not?
Yes, sir.
Yes, sir.
So that is going to increase the temperature. That's why I say use eco-friendly gases. Like the air conditioning earlier, most of the air conditions used to have greenhouse gases, but now they are coming to much more eco-friendly gases. So the process of going through a biomethanation, we need to be cautious. Either we should make the degradation happen naturally with the in terms of oxygen, so that we don't let it into we just go into a decomposition without methane being produced. If we go through a process in which methane is being produced, then we should be capture it and try to utilize it. Once you utilize it, changes its form from methane into another output, which is much more safer. That's the reason. But methane is a very good source of energy, wherein it can be used for various purposes. It could be used as a household kitchen. It could be used in the industries for combustion, rather than looking out for another source of non-renewable energy. Vermicomposting is simple as that. Worms are used here, in which the worms digest the material and the excreta from the worms turns out to be as a very good organic fertilizers. And what we term the output of it is what we call as a black gold. This is the output of what is vermicomposting. Another is organic waste converter. Organic waste converters, I'll show you. This is the same process as biomethanation. But here, it is a machinery which is used.
So your screen is not visible, sir.
Yeah, just a minute. I'm just finding it. So this is just a search on organic waste converter. This is a machinery wherein used. There are various types of machineries available, and there are various forms, simpler forms also. What this does is the same process which happens in the nature. Here it goes through a very controlled process of shredding down of waste, shredding down of any material, which is organic material, and then it goes through a process of decomposition through bacteria, which is induced by us, which is into the mission, and then a segregation of sludge, which is the waste decomposed and the product is removed. Okay, I'll just show you. If you can see this the machine's got shredders where it crumbles the materials and makes it into a liquid state, where it becomes a much more easier process to decompose in a faster way. And again, the biogas is extracted from it, and what is remaining out of the sludge is used as it's a very concentrated material. Once it can be diluted with water, it can be used as fertilizers. So here there are various machineries which are being shown. Organic waste converter using tanks. These are much more smaller because they come in all sizes. The much more local domestic uses. From water tanks itself. Yes. So these kind of organic, again, what you see here, this does the same thing. This is again an organic waste converter, but this is in a much more simpler form. What I showed you is much more on an industrial scale. So they come in all sizes. These are ones which are what you can see here. From these kind of tanks also can be made. But that includes a lot of manual process. So these are the emerging processing techniques in waste management. Hope you guys understood the session. Any questions, guys? Anything which you didn't understand? Anything you want me to rephrase? You guys have doubts regarding waste management? Guys,
No, sir.
questions?
Awesome.
Everyone's clear with this whole lecture, what is happening, waste minimization.
Yes, sir.
This if you can
Yes, sir.
relate to your own use, you'll be able to understand. As like if I want to buy fruit or vegetable, first of all, I need to see what is the stock of material I have. Then I cautiously buy the quantity which I'd be able to consume, and then so that I don't produce much waste, rather I exhaust everything. What is the point if I don't even know what is stock I'm holding, but I'm going to buy so much excess in quantity? I think this we as architects we do a lot with stationery. We buy these big bottles of paints, inks, but comparatively we see we'll have a very minimal usage. By the time we think of using it again, either it gets dried up or it gets expired. So these are few examples in which we can relate ourselves to waste minimization.
Sir,
Yes, yes, Gayatri.
now, speaking of this reusing stuff, sir, so
Yes,
you can either reuse things when they are in their organic nature, like you have some organic waste, it can be done into something, or you have energy waste like thermal or something else, you can reuse it probably. But what if it comes to hazardous waste and chemical waste? They need to be like eventually
yes.
disposed and
The only
incinerated.
hazardous and chemical waste is a very good point what you brought in. A lot of these waste, what we produce. One example I can tell you. To an extent, this one example of hazardous waste. You guys heard of what fly ash?
Yes, sir.
Is it a good waste or a bad waste?
It's a bad waste.
Yes. But again, the fly ash can be used on a comparatively safer method by using a very less amount of it, not guys, I won't say very less amount of it, not entirely making a brick out of fly ash, but a fly ash can be used as one of the composite material in the manufacturing of brick, in which it can be utilized in a form which is not hazardous. Rather, if we are not going to use that fly ash, it has to go through some landfill, which is going to be much more harmful. But is there a way in which we can avoid fly ash from production? No, because any source, as in like from the chars, what we use as coals to burn for thermal energy, we will definitely end up producing that. And with regarding to much more hazardous waste, like radioactive waste, is one of the difficult ways to in which we can think of disposing it. What we can do, the best example is what we just saw: waste minimization. We have to lose our dependency with nuclear projects so that we don't, first of all, use the material at all. Nuclear waste is something what you bring in two materials and then bring in a fusion. But why is that? If there is no use for that material, we are not going to produce anything, right? So we can try minimizing. Whereas again, medical waste, which is totally unavoidable, that we can think of not producing any medical waste at all. We will definitely go through it, but we can try to minimize to a extent. So this is what I think I can answer you on this, Gayatri.
Yes, sir.
Any other question, guys? Anything else? Anything which, okay, any ideas also? Probably you would have seen something. You can share it here now. Some technology regarding waste management. The others can also get enlightened, right? You guys have no thoughts on this? Do have some readings, definitely. See, now we're going to have a model exam coming up, and all of these, unless you guys going to have your readings, what I say is that we can, again, these are examples, few examples which I look into and I'm going to bring it up. But you can explore more and you can bring in all your thoughts. That going to be definitely useful for you in the profession as well as in your own lifestyle. fine. You guys, if you guys don't have any doubts, you can close the class.
Yes, sir.
You guys have still any doubts? Can I get some response here from the class?
No doubts, sir.
Okay. So I've floated the attendance in GCR. Do mark your attendance in GCR. And yeah, thank you guys. Thank you for your time.
Thank you, sir.
Thank you, sir.
Thank you.
Yeah.
Thank you, sir.
Thank you, sir.
Yes.